Greetings, West Springfield High School geometry students. This video we are going to be discussing topic 18b, where we are talking about the converse of the Pythagorean theorem. Okay, so as a refresher, the Pythagorean theorem tells us that if a triangle is a right triangle, then a squared plus b squared equals c squared. Okay? If you think all the way back to earlier in the year about the work that we did on conditional statements, what I hope you all will remember is that with the converse, all we are doing is flipping our terms. So the converse of the Pythagorean theorem says that if a squared plus b squared equals c squared, then our triangle is a right triangle. If it does not equal a squared plus b squared, or if c squared does not equal a squared plus b squared, then it means something else, and we're going to take a look at what exactly that is as we go through this video. Okay. First and foremost, I have an example here of a question that we might be asked at some point, and they would say something like, is xyz a right triangle if xy equals 8, yz equals 11, and xz equals 10 times the square root of 2. Now, in an example like this, one thing that you would want to do is you would want to plug into your calculator 10 times the square root of 2 and see what it gives you, because we need to figure out which one of these sides is the longest side, because that's going to tell us what our hypotenuse is and consequently what our c measure, what our c value is going to be. Okay, now if you put 10 times the square root of 2 into your calculator, you're going to get 14.14, which means of the sides that we have here, that is the longest one. So xz, or 10 times the square root of 2, that is going to be our hypotenuse, which means 10 times the square root of 2 is what's going to go into the Pythagorean theorem in place of c. So again, always start every Pythagorean theorem problem I do by writing the Pythagorean theorem down. And the reason I have the question mark here is because I want to know if a squared plus b squared is equal to c squared. That's going to tell me whether or not this is a right triangle. Okay? So I've plugged the values for my two legs, 8 and 11, in place of a and b, and then I've got my hypotenuse, my longest side, 10 times the square root of 2, plugged in place of c. And I'm just going to go down and simplify all of this. 8 squared gives me 64. 11 squared gives me 121. 10 times the square root of 2 squared gives me 200. When I add 64 and 121, I get 185, and I want to know if that is equal to 200. Obviously it is not, which tells me that these side lengths are not the side lengths of a right triangle. Okay? If they were, then these two terms would be equal to one another. A squared plus b squared would be equal to c squared. But because it is not, we know that what they've given us here are not the measurements of a right triangle. Okay, another example that you might see, or that we are going to discuss here, is very similar. They say, is ABC a right triangle if AB equals 3, BC equals 3 times the square root of 3, and AC equals 6. Now here again, you would want to put 3 times the square root of 3 excuse me, into your calculator to see what that converts to. And when you put it in, you find that it equals about 5.2, which means that AC is going to be our longest side here, and that's going to be our hypotenuse. So, again, writing out the Pythagorean theorem, do it for every Pythagorean theorem problem I do. Remember, 6 is our longest side, so that's what's going to go in place of c. All right? 3 squared plus 3 times the square root of 3 squared, so these are my two legs, and I want to know if when I add these two things together, I get 6 squared. 3 squared gives me 9. 3 times the square root of 3 squared gives me 27, and I want to know if the sum of those two terms is equal to 36. 9 plus 27 does give me 36, so they are equal, which means that these are the lengths of a right triangle. Okay? Now, a little bit more on the converse of the Pythagorean theorem. Okay, we have already talked about the fact that if a squared plus b squared is equal to c squared, let me move this up a little so you can see it. If a squared plus b squared is equal to c squared, then the triangle that we are discussing is a right triangle. Okay, that is not, however, the only outcome that we could see in examples like this. If a squared plus b squared is greater than c squared, then the triangle that we have would be acute. And if a squared plus b squared is less than c squared, then our triangle would be obtuse. Okay, so some examples of problems that we might see where we would be asked to answer a question like this. I'll put this up in just a second here. Okay, so one question that we might be asked here would be, is a triangle ABC with AB equal to BC equal to 4 and AC equal to 4 right obtuse, or a right obtuse, or acute triangle? Okay, and here with an example like this, our longest side is our side AB, which is 5 units. And so that's going to be our hypotenuse. AB would be our hypotenuse, and then AC and BC, those would be our 2 legs. So I'm going to set up the Pythagorean theorem, a squared plus b squared, and I'm not going to say that it's equal to because I don't know if it's equal to. I know that it's either going to be equal to, greater than, or less than, but that's what I'm trying to find out here, which is why I just left this space here. Okay? Again, my hypotenuse is going to be 5, so that's what goes in place of C with the Pythagorean theorem, and then my other 2 legs are 4 units long, so each of those is going to be 4 squared. When I square 4, I get 16, and I want to know if 16 plus 16 is equal to 25. 16 plus 16 is not equal to 25, it's equal to 32. And because 32 is greater than 25, or because a squared plus b squared, in this case, would be greater than c squared, that tells us that we have an acute triangle. Okay, because a squared plus b squared is greater than c squared, we have an acute triangle. All right. One other example of a problem like this that we might see. It says a triangle has side lengths of 4 times the square root of 3, 5 times the square root of 2, and 10. And they ask us if the triangle is right, acute, or obtuse. Now again, here you would want to plug 4 times the square root of 3 and 5 times the square root of 2 into your calculator so that you can figure out what the longest side of your triangle is. When you plug 4 times the square root of 3 in, you get 6.93. 5 times the square root of 2 gives you 7.07, and the other side is 10. So 10 is going to be our hypotenuse. That is going to be our C value. And then these other 2 lengths here, those will be our legs. Okay, so we're going to say a squared plus b squared, and again, we don't know whether it's equal to, greater than, or less than. So I'm going to go ahead and plug all of the values in here that I've got. And remember, our legs don't matter. Our hypotenuse has to be in the right place. Our legs can be, it doesn't matter which leg we make A and which leg we make B. But the hypotenuse has to be C. Okay, so 4 times the square root of 3 squared plus 5 times the square root of 2 squared. And we want to know what that is relative to 10 squared. 4 times the square root of 3 squared gives me 48. 5 times the square root of 2 squared, 5 times the square root of 2 squared, gives me 50, and I want to know what that is relative to 100. 48 plus 50 gives me 98, and that is less than 100. So, because a squared plus b squared is less than c squared, we know that this triangle, or that these measurements, are the measurements of an obtuse triangle. Okay? That's all we've got for topic 18, guys. Thanks for watching.